Hello. What you're looking at here is a 48-inch long Foster Featherweight Camelback level. I was asked by a customer to do the machining on this. He's going to do the scraping. He wanted me to do the machining. I took some video of it while I was doing it. I didn't really have an intention of posting it on YouTube. So it's just sort of random mismatch of clips that I did for my own sort of record keeping, so I would remember how I had set this one up in case I ever got this job again. I learned quite a bit. I'm glad I did this job. I learned quite a bit. Learned some things about my machine and about temperature management when you're trying to do very accurate work. And what I'm hoping is the customer I did this for, I would like him to just let me know when he goes to actually scrape it, to let me know what kind of shape it was in after I was done with it, how straight everything was. It'll help me get an idea of how accurate my machine is when it's actually making parts. In the first scene, there's really not much talking through any of this stuff. I was just filming it for my own use. But in the first scene, I was fly cutting the bottom. The first setup I did was to machine the bottom, so I'd have the largest reference surface for setting up to do this side and then doing the angle. It was a bit of a setup. I wanted to hold it on 3 points to reduce the amount of distortion from clamping. It's hard, like it's difficult to set a casting like this up because there's no machine surfaces, so you're trying to clamp it rigidly and without distortion. And what I did was when I laid it down, it was actually sitting on this face here. I put 1, 2, 3 blocks on this part of the rib, roughly about here. I think it was roughly about here, and then one about here to get my 3-point contact. And of course, it's a cast surface. The 1, 2, 3 block is nice and flat. So what I did was I set the blocks down, set the straight edge on it, and then I shifted the blocks around until it didn't rock, till it felt very stable. Then what I did was I grabbed the 1, 2, 3 blocks and I tried to wiggle them around and find out where they were hinging or pivoting, to find out, the idea of that was to find out where is the casting actually touching the 1, 2, 3 block. And then when I figured out where it was touching from doing that, then I put a stack of nuts. I needed something small because my clamps are wide, and I actually wanted to just clamp directly over where it was touching the 1, 2, 3 block. So I put nuts underneath and then clamped down on the nuts. The idea being that the 1, 2, 3 block is touching at a point. I'm pressing down directly above that point and hopefully not inducing any deflection into the casting. So you'll see in the scene, I think I show the nuts underneath the clamps. What happened was the setup seemed to be okay, but it's a bit flimsy. So I roughed it out with this face mill. That's 10 inserts. And it caused a little chatter at the ends where it wasn't well supported. So then I decided to fly cut it for the last pass because it's very low tool pressure and I shouldn't get much chatter. And this is my fly cutting setup. It's an old boring head, and it's nice in that it's got a square cross hole. So I bought a Sandvik, just like a lathe tool. I think it's 5/8 in diameter, 5/8 square, with a nice positive CCMT insert, so it's got very low tool pressure. And in that first scene, that's what I'm doing. I'm fly cutting it across the length. It worked good. The cut took a long time. It was approximately 56 minutes to make one pass. And I discovered something about my machine, something that I had read about boring mills in the past, that you have to watch. If you start out running them cold and they warm up, the spindle gets longer, because the spindle in this machine is about 4 feet long. It's locked way back there, and it's got all this length over which it can grow outwards. And sure enough, after I did the fly cutting pass, I ran a dial indicator down it, and you should get zero deflection because it's traveling down the same path it just was when it cut. And I actually got about a 2.5 thou deflection over what turned out to be the first third of the cut that I made. And I think what happened was, this is about an hour to do a pass, so it's about 20 minutes for each third of the length. So I think what happened was in the first third of the cut, at 20 minutes, the headstock warmed up, reached a steady state temperature, and the spindle stopped growing. So in the first 20 minutes, I got a deviation of 2.5 thou. Then in the last 40 minutes, or the last 2/3 of the cut, there's absolutely no deflection on the dial. And I think that's what happened. So what I did was I let the straight edge sit for about half an hour to stabilize its temperature. I don't think there was much of a temperature increase from fly cutting. It's a pretty low power operation. But I left the headstock running at the fly cutting speed for half an hour to make sure that it was stable. Then I repeated the fly cut, repeated the test with the indicator, and I got kind of similar results. In the first third there was a change, but this time it was less than 1/2 thou instead of 2.5. So I think that helped to stabilize it. So, you know, it is something you have to consider when you're taking very long cuts with a boring mill. It's probably wise to let it run for a while and warm up. Anyways, when I got the bottom done, I then set up and machined the back surface. And because I now had a flat surface to mount on, and I could clamp over its length, kind of just like how I clamped here, I was able to just do it with the face mill. I didn't need to fly cut it because it was a rigid enough setup. And same thing though, I roughed it out. Then I let it sit for probably a good half an hour to stabilize. I left the headstock running. I took my final pass. I didn't run an indicator down that one, but I would assume I would have gotten similar results. Then I think it's in the third scene, I had mounted these 1, 2, 3 blocks at each end. They were going this way. I ran them down with a dial indicator to make sure they were in the same plane. They were in line to less than 1/2 thou, and then I butted up this machine surface up against them, just like you see, clamped it down, and then cut this angle. I had to do the angle. This was the cutter I used. It's a single angle 45-degree cutter. And unfortunately, it's just not quite big enough to cut that full angle. So I had to do it I had to reset the tool and, move it up and in to do the final pass. You can see a line where the cuts overlap, and it looks kind of bad, but when you feel it with your finger, you can just barely feel it. You put a ruler and a light behind it, and there's barely anything. So it's actually matched pretty close. And then in the end, I machined the ends and just used the rotary table to present those faces to the face mill to cut them. So I may have mentioned this earlier, I'm gonna ask the customer if he can tell me what kind of shape this is in when he goes to scrape it. That'll give you an idea of the accuracy of the machine and my ability to make the cuts accurate. So I would do things a little bit differently if I did another one. The setup, I would probably change the initial setup a bit and actually mount it on points. I do have these jacks here. I didn't think to use them at the beginning. That have a bit of a point on them. I could probably mount on that. And then on my clamp, I may make something even smaller. These were the nuts here I used. I would probably get something even smaller than this that could sit directly above this point to reduce any deflection. So anyways, that was my first crack at one of these. I hope it goes well. I'll find out later on.
One of the advantages of having the built-in rotary table on boring mill, when you have jobs like this that are hanging over the table on 3 sides, you can really take advantage of it. I set it up to machine the angle here, and when I got that done, I rotated the table 90 degrees, and then I machined that surface, and now I want to rotate it 180 and put this rough surface facing the cutter so I can machine it as well. And that's really all there is to it. There, ready to machine. It's a lot quicker than taking it off, setting it up at 90 degrees with a square and clamping it all down again.